We'll continue with switches today. We're going to do configuring VLANs. VLANs are virtual local area networks. In a local area network, we would have, let me see if I can scroll on this a little bit. What we would kind of have is a switch here, and I'm not doing my nice boxes, and a switch here, and we would have our computers connected here and connected here, and this could be a network, a 192.168.1.0 network, and over here a 192.168.2.0 network. And then we would use a router to connect these things together. We're always going to have a router to connect the individual networks together, but what we're trying to do with VLANs is to take this switch with its ports and break it up into different networks. At this part of the switch is 192.168.1. This part of the switch is 192.168.2. This part of the switch is 192.168.3. What we're doing is we're creating broadcast domains. Broadcast domains, layer 3 function, networking. Routers connect these things together. And it's kind of a neat way to do things when you think about it, that we can, with a layer 2 configuration, create a layer 3 circumstance. And why would you want to use this? Let's say that, let's just say that we have, maybe this would be in a classroom. Actually, let's just do one here, in a classroom. And we have the students here, and we have the faculty over here. They're going to be on different networks. So what we can do in the classroom is we put the students on the student network where they get their resources, and the faculty on the faculty network where they get its faculty resources. So they're on the same physical device, but they're on different logical or virtual networks to do these things. We're still going to have to, and the last thing that we'll do today, not today, but in this switching area, is we will create a system that we don't have to have so many ports to do these things. We could make all of this work on the networks if we did this one instead of doing this, and we'll have some other things. We're going to create a thing called a trunk port, which is going to allow all of our VLANs to transit it. And we're going to create a thing called a router on a stick and switch virtual interfaces. We'll look at those on how to make these things communicate more efficiently without having to have an interface. Because if we then had another switch here, we have to have an interface and another switch. Eventually, we're going to run out of interfaces on the router. We could also, and I said we have this trunk port, we could also create a situation that we have a port on each of the VLANs, or we could just go buy a bunch of switches. Probably going to be more efficient to do that. You know, and I used to have that situation. Go into a classroom and I'm on the student network, and I forgot to bring something, or I couldn't do it. I needed to get to my home directory. I couldn't get there because the students couldn't get to the faculty network. Put a VLAN in, put the faculty machine in the classroom on the faculty network. Now I can get to the resources. What this allows us to do, again, is to create broadcast domains. I think what I want to do is my little demo here for what goes on. It's got a whole bunch of different things here, but the first thing is that it is going to create a broadcast domain for each of these things. These guys in this switch here are not in a situation where we've created VLANs. Down here in the green and the blue, we will. We're going to get to there in just a second. So what I want to do is to go into the simulation mode here, and let's ping the broadcast address. Ping 192.168.1.255. and see where all of that traffic goes. And it goes into the switch, flooded out all of the ports except the port that came in, and it goes to everything. And that's the issue that we have. We can separate these IP networks, and they don't talk to each other, because you see this one, these guys over here, it's got it, these guys over here got the red X, which says, hey, this is not to me, this is not to my IP address, not to my network. And the answers are going to come back to the originating station. But what we're trying to do with VLANs is to eliminate that broadcast or isolate the broadcast domains. I have over here, let me get over here on this one, I have one that's messed up, and we're going to go through, look at some things and fix it, talk about some of the terminology, and then we'll go and do the slides, which will hopefully review those things. But I have these guys broken up into broadcast domains, but there are a couple of things that go on here that happen or don't happen. And when we talk about troubleshooting, you know, what could go wrong? We've got these guys are connected to a switch, and their addresses are 3.3, 3.5, and 3.6. I don't know where 3.4 is. It's over here. So let's see if 3.3 can ping 3.5. Same network, right? So they should be able to do that. Let's ping 192.168.3.5. Yep, can do that. How about 3.6? That was the next one, right? 3.6. I can't get there. That's kind of frustrating when I got them plugged into the same switch and they can't communicate with each other. And the reason they can't communicate with each other, I'll tell you right now, is because they're on different VLANs. The VLAN has been misconfigured on purpose in order to do that. So let's then see if we can go from one switch to the other switch. And I'm going to, instead I've got this set up to where it will work, won't work, will only work with certain things to try to illustrate these things. Let's see if we can go to 3.6 to 3.8. So let's ping 192.168.3. You can see at the top there it worked. I just tried this out this morning to be sure that I still had it broken. 3.7 we can't get to. 3.7 is on that same switch as 3.8, but we can't get there. We can't get here from there to there. So how about 3.3 to 3.4? 3.3 and 3.5 could talk to each other. So can these guys go across here? And that was 3.5 to what? 3.4. Let's ping 3.4, and he can't get there. The reason that they can't is because of VLANs. And these guys are Fast Ethernet 0, 1, 2, and 3. If I go into this switch and use a show VLAN, it shows me my virtual local area networks. When you create these things, and there are some other ones here, we'll do that. It's not real difficult to create them. It just go to config T and type VLAN and then whatever number you want it to be. But we have the original here, which is going to be on everyone. We'll look at a fresh one here in just a second. VLAN 1 is the default VLAN. Everything by default is on the default VLAN. Kind of makes sense, doesn't it? Active. And then we can see over here a list of ports that are there. We have created VLAN 2, the .2 network, and one of the things that I kind of recommend, and sometimes I deviate from my recommendations for myself, is that you number these things kind of in an orderly method. This one I did 2 for the 192.168.2 network, the .2 network, and 3 for the .3 network. Doesn't seem like a lot now, but when you get a lot of these things going on, it can become kind of confusing. So the guys that we had were Fast Ethernet 0, 1, 0, 2, and 0, 3. So 0, 3 is up here on VLAN 1. It's in a separate IP VLAN, virtual local area network, a separate IP virtual boundary, virtual isolation. So what we need to do is put Fast Ethernet 03 onto VLAN 3. And the way we would do that is to go to the interface, go to the config, the global configuration mode, config T, interface, Fast Ethernet 03, and we just say switch port access VLAN 3 when we do that. Now then, let's see if this guy 3.3 can talk to 3.6. 3.3 to 3.6, and we're in business. 6 could talk to 8 before, and let's see if he can do that now. And I think the answer is going to be no. And the reason the answer is no is because when we go back and look at this and the port connecting these guys, gig 01, let's go back into the show VLAN. Let's just get out of here. And show VLAN. The gig 01 is in VLAN 1. It ain't in VLAN 3. We could put it in VLAN 3, then they could communicate with each other. We could make another connector between these guys. Remember that spanning tree is on a per VLAN basis. We could connect have another connector and do the .2 network and another one for the 100 network. Eventually we're going to just have the switches connected together, not have anything accessing it. We have a way to allow all of the VLANs to transit between the switches, and this would be in the inter VLAN switching. And then we have this thing called a trunk port. And the trunk port allows all of the VLANs to go from one to the other, to go across it. What happens as the frame leaves the switch, it gets a marker, a shim stuck into it. 802.1q, another one of those 802.1 something and others, 802. something and others, but 802.1q. In Cisco, when you want to use it, it's just .1q. You don't have to put the 802 in there, but the configuration term is .1q when we do that. It can be used here when that happens as the frame leaves the switch, the shim, the 802.1q 4-byte field gets put in it. It's got some other information in it, like quality of service, but it also has the VLAN number. Because it says that, hey, when you get to the other end, here's the marking, tell the other switch that you're going to the .3 network. And the other switch will then only send that to the .3 network. So let's go ahead and do that, and we'll get into the dynamic trunking protocol, and that's what DTP is all about. So we'll go to config T and go interface gig 001. And you can do gig, and I can do the tab here and get the gigabit 0/1, and then whatever we're going to do. And its term is going to be switch port mode trunk. We're going to change the trunking mode to it. Line protocol state is up. It says that it is now there. The way that I can find out if that is in fact the case, I can do a show interface trunk, and it says, okay, I have an interface called a trunk, and it's on to do these things, and the VLANs that are allowed and all that other good stuff. If I go back and do a show VLAN, you notice that gig 01 doesn't show up anywhere anymore. Trunk ports are members of all of the VLANs. The other port type that we have is an access port, which is a member of one VLAN, can only belong to one VLAN. So now then, And the problem with 3.8 is the same as it was with this one. You notice the spanning tree is still going on, so we'll delay here a couple of seconds. We got to wait for our 50 seconds because this is per VLAN spanning tree protocol. Okay, now we're there. I'm not going to change this. It's on the wrong VLAN. It's still on VLAN 1. So let's see if we can go from 3.6 to 3.7. We still shouldn't be able to get to 3.8. I got the wrong device, didn't I? 3.6 to 3.7. 3.7, and sure enough, we're there. What we've done, and we can go to the 3.8, and it's not going to work because it's still on the wrong VLAN. It's still misconfigured. What we have, and I want to do that broadcast thing again. I didn't want to do that. Do the broadcast. I got the wrong device here. I'll do the broadcast thing here again and see what happens in this situation. So let me move this back over here. We'll go into simulation mode again. Go back to this guy and let's ping its broadcast address. This is the 3 network. Gotta get in the right place though, don't I? So let's ping 192.168.3.255. When I do that now and start these packets going, goes into the switch, out all of the ports on its VLAN, goes across the trunk port. When it gets to the other switch, goes to all of the devices on its VLAN. You notice it didn't go to 3.8 because 3.8 is still on VLAN 1 to do those things. And then the answers are going to come back to the device to do those things. So they're all responding. These guys here, and you notice it just goes out the trunk port because it now the switch knows which port all the MAC addresses are on. When we go from one to the other. So we've created a broadcast domain. I said that we would look at, let me get back to real time. Let me get down here and let's bring a fresh switch in here. And when we look at the show VLAN, again, the flash, what's going on, and then the information that you get at startup that's there. The pound signs is decompressing the iOS. Then let's do a show VLAN. And these are kind of things that they will like for you to know about. The first VLAN, the default VLAN, VLAN 1, and this is one that you can't delete, you can't rename, you can't do anything with it except live with it. We can, as you saw, take ports off of it and put it on other VLANs. So we don't have to actually have any of the ports assigned to it as long as we're using everything else. Then we have these down here, 1002 to 1005. And these are the kind of things that people typically like to ask. These guys are pre-configured. They're not used anymore, but they are pre-configured. They've never changed it. FDDI token ring, FDDI net, TRNet. Protocols that we're not using anymore are there. So we can create on our own accord VLANs number 1 to 1001, and we can assign ports to them. We access the switches with the access ports. We allow all of the VLANs to go from one switch to another using trunk ports. And trunk ports, here they'll say, member of all of the VLANs. They have the capability, they transmit the information, and they do the tagging. That's where the 802.1q, the .1q protocol comes in. It didn't ask me to do that on the layer 2 switch because it's the only protocol that is there when we do those things. Let me just get this out of the way now that we're off of the first slide here, the flat network structure. This is the standard that we have, and this is the broadcast that we saw earlier. With this configuration, every broadcast packet is transmitted is seen by every device on the network. Why is that significant? We don't have any isolation from the broadcast. Somebody could say, oh, you know, what's going on? What's going on here? The broadcast. Hey, I want to be on that other network because that's the payroll network. And if I can give myself an IP address on the payroll network, since we don't have any isolation here, I can get there. I can do what I need to do to get from one to the other. So one of the disadvantages is everybody's going to see, everybody's going to have the, well, everybody's going to see, they're going to have the capability to see if you put the NIC into promiscuous mode, all of the broadcast traffic, because the broadcast traffic goes out all the ports all the time. That's what it's designed to do. It's designed to communicate with everything when we look at it too far here. In this one, the sales shows that all the hosts in this very small company is connected to one switch, which means that all the hosts will receive all the frames, which is the default behavior of the switches. That's what they do, the broadcast frames here. Receive frames, which the default connected to show all the hosts in this very small company connected to one switch, meaning hosts will receive all the frames, the broadcast frames, that go to them. The switches we know is going to create the MAC address table, and when we do the unicast one-to-one, it's only going to go to the device that it's designed to go to. When we do VLANs, which we just did in the demo, we have one switch, two virtual local area networks, logical separation of hosts, still physically one switch. We saw that, we did the broadcast on at least one network, and it went only to the devices that were in that VLAN. Still physically one switch, but it acts as many separate switches. And we did this. We had two devices in a DMZ, and instead of taking up a whole switch, created a VLAN, created a DMZ VLAN, connected those devices to the DMZ VLAN, and then used the other ports, the other 22 ports, for other reasons, other purposes to do these things. So one switch can be multiple VLANs. You can have one per port if you really wanted to. It wouldn't make a whole lot of sense, but you can do that kind of separation should it be required. Helps you to do some isolation as well as to do a little bit better utilization of the resources that you have, because people usually aren't real crazy about spending money. You say, I need a new switch because we have a this or a that. And we got three people connected, three devices connected to this switch. Well, they're probably not going to like that a whole lot. So now we can connect multiple users, and maybe they're in the same room, same floor, same whatever, same building. We can have multiple users in different locations on the same network, which can be handy for us. We're always going to have a router, and this one here just shows a single interface, and we will configure this a little later today. This is called a router on a stick because physically it looks like a router on a stick. We only use one interface, and we're going to use sub-interfaces. So we're going to find out about sub-interfaces here a little bit later today in order to do that. We have multiple IP addresses on a single physical interface. VLAN is a logical network that groups devices into a single broadcast domain. And that's again what I was trying to show as we went through that, and some of the things that we can have, some of the configuration errors that we can have with it also. We do that. In a local area network, all the interfaces of a switch are in one broadcast domain. That was the first one that we did. Those were actually on two different networks. I didn't actually show that. I guess we're on the one network, and we're on the 100 network. We can go back and look at that. The one that was up here, the original that we did. These guys are 100.1 and 100.2 with a 24-bit mask. And these guys are 1.3, 1.2, 1.4 and 1.5. So the 192.168.1 network, the broadcast traffic went to the 192.168.100 network. And those are the things that we're trying to eliminate, minimize, or eliminate with these things, that we're going to have multiple broadcast domains. Single device, pretty simple configuration. How do we make a VLAN? And I'll just go back down here to our original, if I can find our original that we put in here. Here we go. I think this is the one that we were working on. If I wanted to create one, I would just go to config T and do VLAN 33, and we can name it CCNA June. You can't have spaces in the name. You can have numbers. If you want to have spaces, you have to use the underscore key when we do that. So now we can use the do command, do show VLAN, and we have our VLAN 33. We named it June, but you notice we don't have any ports on it. If we wanted to put ports on it, we could go to the ports. And I do exit, I go up one level to the config mode, and this is where we do in and go to the privilege exec, and then go back into config, or just do exit and go up one at a time. So I can go in here and do interface, range, and if we want to do more than one interface, you can do a range of interfaces. Fast Ethernet 0, 1, and let's do 215. So we have this range, and we'll do a switch port. And we have the options here: mode, access, non-negotiate, port security. Some of the things that we will look at. We've done trunk, switch port mode trunk a little bit earlier. Trunk sets the trunking characteristics of this thing. But right now we're just going to do switch port mode, access, and then the VLAN that we're going to do. And that was what, 33. Switch port access VLAN 33. Yeah, this is VLAN 33 would help a lot in this. When you have an error, the caret that you see, that's where the error occurred. So if you do a whole bunch of, and the character that the error occurs, that's back here. This is where the caret's going to be. Invalid attempt at the caret mark. So that's where they're going to be. If we now do a do show VLAN, those ports are now on VLAN 33. I've now got two broadcast domains on this switch. VLAN 1 and VLAN 33 would be there. While we're here and doing these things, let's go in here and let's do no VLAN 33. Let's just make it go away. And now we do a do show VLAN. It's gone, but its ports are gone also. Its ports are now in a black hole. They are not usable. I guess the moral of the story here is, if you're going to delete a VLAN, take all the ports off of it first. If you make this mistake, and we'll go back and do do the same thing here. We recreated VLAN 33. When that VLAN comes back, the ports are still going to be associated with it. So, a couple of things that might happen to you here that created, I accidentally deleted it. The name doesn't come back, VLAN 33, and the number, but all the ports are now associated with it. We could go to VLAN 33 and rename it if we wanted to use it, or we could now move those ports to a different VLAN, back to VLAN 1 or wherever we wanted to go, and then delete VLAN 33 to make it go away. So we have those things. Broadcast domains are going to be here. One host in a VLAN transmits a broadcast packet. All the other ones in the VLAN receive that packet. Again, what I was trying to show, do the visual in the packet tracer demo that we had. The hosts that are in the other VLANs don't receive the packet. When we had the VLAN set up working properly, not only did it go to the ones in that VLAN on that switch, it went across the trunk port that we had configured, the one that allows all of the VLANs to transit it, and I guess you could think about it as a bridge from one to the other, although bridge probably a bad term to use there. We have bridges, but transit the trunk that goes from one of the switches to the other, and then it can talk to its other VLANs over there. They get tagged. A tag gets put into it, gets inserted into it as it goes into the trunk that says, hey, you're a member of VLAN 33. When you get to the other side, tell the switch at the other side that I'm a member of VLAN 33, and it will send you off to all of your VLAN 33 buddies that you can talk to them. Routers on a layer 3 switch are needed to transmit, routers or a layer 3 switch are needed to transmit packets between multiple VLANs. They're different IP networks. It doesn't matter whether it's a virtual local area network, whether we have switches configured with different local area networks on each switch. We still have to have a router to allow communication between different networks. That's always going to be the case. So layer 3 device to get to different layer 3 areas. Picture here kind of what we might have in the different configurations, different VLAN configurations. We got the, with the VLAN 20, we got a staff here on VLAN 20, finance, VLAN 20. That's not going to work. VLAN 20, VLAN 20. This should be a different VLAN number. VLAN 1 is the default VLAN. 10 is the admin. Finance here, let's say that's on 30 or 40 or something like that. When we do those things, I think that is an image that maybe I can. Let's change that one. Let's make them VLAN 30 because we got 10, 20, and 30 now. All right. Different VLANs. These guys are in the same broadcast domain, same broadcast domain, same broadcast domain. We have a router out here that can now be configured to communicate between all of the different IP networks that are available here for this. So that's what we're doing with these devices, with this configuration, with these virtual local area networks, is we're isolating. And when you think about it, we might have finance people maybe in different offices, different physical locations, maybe even on different floors of the building, maybe even in different buildings. We could then allow them to be on the same IP network, the same broadcast network, and they communicate with each other, and all we got to do is connect our switches together with trunk ports so that they communicate with each other when we do these things. It shows IP phones in here. The IP phones are going to have their own VLAN. We're going to separate the voice traffic from the data traffic so that somebody on the data VLAN, one of the data VLANs, can't intercept the phone calls to do those things. So they should have their own very own private VLAN when we do those things. We're continuing with these, the VLAN ranges we just looked at, the 0 to 4095, and 4095 includes the extended range. If you look at the chart at the bottom, VLAN ID 1 is the default VLAN. It's always going to be there. It's always going to be with us. You can't delete it. You can't rename it. Can't make it go away. 1 to 1005. The 1000 and 1002 to 1005 are always going to be with us. They're there by default. You can't delete them. You can't rename them. You can't make them go away. The things that are created by the system are going to be part of the system. And then we have the extended range VLANs 1006 to 4094. 0, VLAN 0, and VLAN 4095 reserved for system use when we do those things. 1, 1002 to 1005 are in the default, are all default VLANs. The default VLANs can't be modified. These are the ones, again, I guess I should have just done the bullets here. 1 to 1005 are in the normal range. 1006 to 4094 are in the extended range of VLANs. And there, the configurations or the normal VLANs are stored in the VLAN database, the VLAN.dat file. When we do those things, in VRAM or flash, and it might be in either one of those. Let's see if we can see it in this one, and let's see, show flash. I'm going to spell an E-N right. Can you do that? Show flash. Can't spell flash either. So the VLAN.dat, in this particular one, the data file for the VLAN, and because we created, they're there, we made some, is stored in this area. In this case, it's in flash, so it'll be in one of those areas, in VRAM, non-volatile RAM, where the startup config file is stored, or in flash, dependent upon which switch model we have. Configurations of extended VLANs, and here we got a term VTP, the VLAN trunking protocol, which we were going to do, but we haven't done yet. There are going to be 3 versions, 1, 2, and 3. And the extended VLANs, the VTP version 3 only, they're stored in the server client or transparent modes. Things that, again, we haven't done yet, but we will when we do that. Transparent mode only updates locally when we look at those, and we'll demonstrate those in a little bit. The running configuration file in transparent mode is where these things are going to be stored to do that. The default VLAN, VLAN 1 is the default VLAN. Can't be modified, renamed, removed. And the native VLAN can be modified. The native VLAN is kind of a, I guess not a different, but it's a concept that is there for old equipment, the things that we don't use anymore. Basically, we may have something that gets attached to a device that doesn't know anything about tagging. A hub, for instance, could be there. So the native VLAN, when we talked about tag, and the tag gets put in the trunk and all that other stuff, but the native VLAN doesn't get tagged, does not get any tags on it, so that if it goes from one to the other and it gets to the other side and the other switch says, hey, I don't see a tag on you, you go to the native VLAN. And the native VLAN is configured on a trunk basis when we do this thing. It says it can be modified, and it can be modified. And I guess we could go in here and see, and it is one of those things that we talk about can kind of be a dangerous thing, because since it is untagged, gig 0 into 0, and let's say you have a trunk here, then if I put myself on a different VLAN and it gets on the untagged VLAN, when I get to the other side, I'm going to swap from one to the other. Show interface trunk, and we have one here. Let's go to interface gig 0/1 and config T. Interface gig 0/1. Let's see, let's do switch port, and I've forgotten exactly where we're going here. Trunk, native, and then we can say VLAN, and then we can put it on one of the other VLANs. Let's do VLAN 500 since it exists on this one. It has to be on a VLAN that exists, and I just looked up here to see if we had one that was there. So we have now done that, and it says, hey, you've got a problem, inconsistent local VLAN. If we change this untagged port, then we get a lot of error messages. And it says it's an inconsistent local port. It's unhappy, to say the least, when we do this thing. It still shows as green, but what we can now do, let's say that hacker guy here is on VLAN 100, which is the native VLAN, or 500, which is the native VLAN, the untagged VLAN. So Hacker Guy now transits the trunk here, transits the trunk, and he gives it 500, so he is no tag. So 500, I guess I need to change the colors here, huh? 500, so he goes on 500, which is no tag. It gets over here, and this is the no tag, which is the native, and that's the term we'll use, native. So he's a no tag. He goes across here, gets to the other end, it gets inspected, and it says no tag. Okay, you go to VLAN 1. VLAN 1, and all I say that maybe is the payroll guys. So Hacker Guy has now managed to put himself on the payroll VLAN. Maybe he's going to go hack the payroll server and give himself a raise, something like that. So that is kind of maybe not a smooth way, but that's what becomes dangerous about the native VLAN. Let me go ahead and change this back and stop all these error messages here. And let's go back to VLAN 1, which was this one, I think was set up on VLAN 1. When that happens, now we're back to unblocking gigabit 01 on VLAN 500. The port consistency is restored, so we've now fixed the error. This can be a dangerous situation. VLAN hopping would be the term that we would use there. And if we did that, it could be a dangerous situation. But you saw that if you have this configured improperly, you're getting a whole bunch of error messages that say, hey, you've messed up, fix it. You've messed up, fix it. But the native VLAN can be modified. And you saw it can be modified because we just modified it. Default, all the ports on the Cisco switch are assigned to VLAN 1. VLAN 1 is the native VLAN. VLAN 1, when we start up, is the everything VLAN. It's the default VLAN. All the ports are assigned to it. It's the native VLAN. We're there. We looked at it. We created another VLAN, simple command VLAN, whatever number, and then we can name it. When we do that, until they're configured, and then we can move ports, and we did that, move ports from one VLAN to the other one. VLAN configuration is stored in the VLAN database file, VLAN.dat. In the running configuration file, we did the show, we didn't do the show run, but we did the show VLANs for those things. And then all of the parameters of the default VLAN are set to the default values. Let's do that. Let's go back and look at this thing because I think it's going to show something that maybe we want to talk about here also, or just mention. This is the one that had the VLANs, I think, right? Show VLAN. Yeah, and we have our two here. If we do the show running config file, these are VLAN 33. They are, in fact, in the running config file. And we did up to 15, I think. But you notice that the rest of these guys don't have any designation for the VLAN. When you look at the configuration file, anything that's the default won't show up in the running config file. Any deviation from the default, because by default, everything's in the default VLAN, VLAN 1. These guys are still there. So we don't see VLAN 1. Since we don't see VLAN 1, say, oh, it's the default. They're in the default VLAN. The other ones, when we've made some modifications to it, are going to show up in the configuration file. So anything that is a default, and those are the ones that such and such happened. Why don't you see that? Well, because it's the default. If it's the default, it won't show in the config file. Get rid of those. All the parameters are set to the default values in there. Access ports. The ports associated with one VLAN. The access ports are what we connect our computers to, what we connect our servers to, not what we connect our switches to. And we looked at those. I didn't actually go in and configure them. We can in some of the things that we'll do when we get to port security, for instance. We have to go in and use the command switch port mode access. There are two modes, access mode. A single device is expected to be connected to it. Part of the end devices, the end ports, when we do those things. The VLANs belong to one VLAN and belong to the same broadcast domain. Again, hopefully we saw those things a little earlier. Cannot be used for trunking, and we did configure a trunk. If we configure one port as a switch port mode access, manually configured, and the other one as a switch port mode trunk, gets really confused, doesn't know what to do, and basically winds up doing nothing when we have those things. The commands, switch port mode access, switch port non-negotiate. The ports by default are negotiated ports. And negotiated means it's trying to negotiate to be a trunk. And we'll talk about that when we get to be trunking, but that's where the non-negotiate comes from, which says, hey, don't do any negotiation. You just be a trunk, don't worry about it. Or be a trunk, an access port, don't worry about it. Access is a layer 2 interface for the physical switch port. Two types. We're going to have the data ports and the voice VLANs, the voice ports. I said that they can only connect to one VLAN, and we're going to get to voice VLANs here in a minute, and then I'm going to say, okay, I lied. You can only connect to one data VLAN. You can connect a port to a data VLAN and a voice VLAN to separate those two. So in that case, if we have a voice VLAN configured, we can have it connected to both of them. We can have a computer connected to it, and in fact the phone is a 3-port switch. That allows you, what you do is you connect the phone to the layer 2 switch, and you connect the computer to the phone when we do those things. So we can have the VLAN 50 can be combined in one access switch port. In this case, the phone connects again to the switch, and the computer connects to the phone. The phone kind of labels its own VLAN so that when data gets out onto the switch, we don't have to worry about it. It's already said that it's on the voice VLAN, VLAN 50. And voice VLAN is a special configuration that we would use in order to use the phone. So we're going to separate voice traffic from data traffic. The phone itself that says VLAN 100, the port would be on VLAN 100, would just pass the data from the computer straight through the phone to the data port, or to the port on the switch, the data portion, the data VLAN. And again, the trunk ports are the ones that label the VLANs. They know which ones, the switches know which ones, which VLANs, which configuration, based on the configuration, which VLANs each of the ports are in, so that they know internally which devices are able to communicate with each other. When we use the show MAC address table, one of the things that were there was VLAN. One of the characteristics, I guess, of it was that the VLAN is associated also with the port and with the MAC address, so that the switch knows which of the devices the VLANs can talk to each other from one to the other. VLAN 50, the phones themselves can be on a separate VLAN, a voice VLAN, when the voice VLAN is configured. How do you get to be a member of a VLAN? We've already done one. The static membership is where we go in and configure the port, switch port access VLAN, whatever, or the range of VLANs. Static membership assigns the access ports to a specific VLAN. Kind of a pain. Although actually once you get the configurations done, these are not going to change a whole lot. There's an awful lot of things we say, oh yeah, this is really difficult. If you have 300 of those, it's a whole lot of trouble. But generally speaking, and this is a generalization, but generally speaking, once you get the configuration set up on the network, it doesn't change a whole lot. You may be adding things, taking things away, but a lot of what you're going to be doing is after the initial configuration, and oh yeah, Jane is abusing certain privileges, you may go write an access control list to restrict that. But a lot of it is going to be just general maintenance that goes on these things. The other method that we can use for VLAN membership is dynamic membership. VMPS, and VMPS is a VLAN management policy server. And the thing to take away of that is dynamic. We got to have this server in order to do that. It dynamically assigns the network to a particular VLAN based upon its MAC address. And if it does that, that means that, hey, we're going to have to do some configuration in order to do that. That could be handy, you know, like the network administrator may be moving around and connecting a machine to a switch, and then when it connects the machine to the switch, it goes to the VMPS server. The VMPS server says, oh yeah, I've got that MAC address. Put it on VLAN whatever the network administrator should be on. Generally, users aren't moving around that much, and this is, I'm not just trying to justify one or the other, but just saying that, yeah, the dynamic membership, we got to go out and buy this server. We have to configure this server. It's a neat concept, it's a neat thing, but it's something that you may or may not need, but it is a capability that is available with the devices. The data access ports are used to transmit user data, used to separated from the voice VLAN and the VLAN control traffic. Oh, a new term here, VLAN control traffic. CDP, a bunch of those, several of those, STP, other protocols are going to be there. They're going to use the native VLAN also when you do that. So the native VLAN, why do we got to have it? Control traffic or management traffic is going to be on the native VLAN to do those things. So what are we going to have on the access ports? File servers, file management, print servers, printers, storage servers, email servers, application access to get to your home directory, to get to your whatever you're using for a word processor, to get to the policies that you're going to use to or the software that you're going to use to implement the policies to install things. Large enterprise network use multiple VLANs. I don't think you have to be a large enterprise network to use multiple VLANs. Maybe not hundreds of VLANs where we would need the that kind of capability, but you may have 4 or 5 or 10, depending on what you're doing. It is probably a good idea to separate a lot of things that go on. The managers from the rest of us, the people that do payroll, the HR certainly needs to be isolated from everybody else because of all of the personally identifiable information that they handle. So VLANs can be used to do that. And again, in a little bit, we'll look at how we're going to connect these VLANs together efficiently. We do that. Not normally configured to carry voice information, but it can be. Normally, we're not going to put our phones on the data VLAN. You can, but generally, normally, and if you think about it logically, we want to create a voice VLAN so that the phone traffic is separate from everything else. Besides, now we can have a higher priority VLAN, and phones will in fact assign themselves a higher priority than the data traffic. The voice access ports, which are used to carry voice traffic. The benefits here: good voice quality, transmission priority, and minimal transmission delays. And this goes back to we really want to have this thing, and it's this emergency phone calls in a congestion network. Voice VLAN. VLAN, we're going to have a higher priority. The data traffic's going to get a priority of like 1, and we're going to get a priority of 5, where we're going from 0 to 7 to do these things. The management frames are going to get the 7 areas. The voice, they are 5 in the 0 to 7 range, and where data is somewhere around 1 or 2 to do these things. So to support emergency calls, congested networks, emergency calls are always the things that we come up with because, emergency calls, we want them to be able to go through. Minimal transmission delays. What you also want are clear phone calls, good quality voice. If you get the wah-wah calls, then you're probably going to get to go see the big managers, and they're going to want to know why. And if you can't fix it very quickly, then you just go and update your resume to do these things. But the voice VLAN, we have a voice VLAN configured separately from the data VLANs for the devices themselves. Together to form a dedicated voice VLAN, can carry VoIP and data traffic. The ports we're talking about here can do that, not the VLANs. They're going to have, this is the one case where a port will access, an access port will access more than one VLAN, but it has to be in a switch that has the configuration here, switch port voice VLAN. We have to have a voice VLAN and then a VLAN ID that goes along with it. Also manage signaling traffic and support the call setup, progress, and disconnect. And these are the frames that are going to be even higher than the voice VLAN. They're going to be in the 7 range, in the 0 to 7 priorities that go with these things. Port security consideration, we'll talk about that. Port security, when we do port security, well, we can mention it here. Port security is basically on a switch we're going to do MAC filtering. So we have to consider that the phone's going to have a MAC address also. We have to take that into consideration when we do port security, and that's what that one's all about. The VLAN connectivity, not always in one VLAN, and this is where we're going to get into the, we're going to do a trunk port. Here's what we're talking about. Not always configured with one switch, is not always configured with one VLAN. Network usually includes multiple switches, with each switch supporting more than one VLAN. Some interfaces may be present in one VLAN, others in other VLANs, and we have that here, VLAN 5, VLAN 6, and VLAN 6 has machines, and we looked at that in our demo. We had the different VLANs on the different switches, and now we need to be able to get the traffic flow from one to the other. As it grows, impossible to set aside one link per VLAN. We could actually do that for a while, but if we have like 4 VLANs on a switch, that means that we have to have 4 other ports to connect together, and then we have to keep doing that from switch to switch to switch to switch, depending on how many switches we have. The trunk port becomes a whole lot easier to do that. And the trunking, and it's pretty simple, as you saw, to configure one, switch port mode trunk. And that's all we do. 2 switch port modes, switch port mode trunk, well, 3 actually. Switch port mode trunk, switch port mode access, and switch port mode dynamic. Dynamic is a negotiation process. To do that. Facilitate traffic flow across the VLANs that exist in multiple switches, and we do tagging for this thing. 802.1q is the protocol that is used to tag the traffic. And again, I know that I beat these things to death, but as it leaves the trunk, leaves the switch, goes into the trunk, it gets tagged. As it comes out of the trunk, the tag gets taken out and it gets sent to its VLAN, because the switch knows which VLANs things are on. If we sent a computer a frame that had an 802.1q shim in it, wouldn't know what to do with it. It'd drop it because it would see it as a damaged frame. The switches know how to handle that. The devices that we use don't. So inter VLAN connectivity, and what this is showing is a layer 3 switch. We're going to do the configuration of those after we do some other switching things here. But we can use either what are called switch virtual interfaces on a layer 3 switch, or a router on a stick using a router, and we'll look at both of them. But the default gateway of the host, this is showing that the different interfaces up here on the layer 3 switch are used to go from one to the other. They're going to be the default gateway for each of the hosts on the different VLANs when we do those. So we are up to, I think, the first lab set.